Service security. Something. I left that word out, sorry. on service-based infrastructure. All right, if you're not going to listen to the talk, would you take the conversation someplace else? It's really loud in here. Red shirts? All right. Robert Lucero is a physics major turned software developer. He has 9 years of software development experience working on various projects at Microsoft and more recently at Okta, an enterprise identity and app management service. And my phone. Oh, good, I got it. Judging by his untapped badges, if you want to know more about him, he'll probably tell you over a beer. But he might make you run a marathon first, or beat him in a video game marathon, or maybe just, pay. So, maybe try that first. But not during the conference, because no alcohol. Instead, please give a warm welcome to the guy who will be telling me where to find all the best beer in town tonight, Robert Lucero.
Awesome. Thanks for that introduction. I had no idea that I would have been researched, or most of that stuff being read. Cool. Hi, everybody. So again, this is when doing the right thing goes wrong, and specifically I'm going to be talking about how certificates-based infrastructure. Uh-oh, thank you. We're learning how microphones work, and I'm pretty bad at this sort of thing. So, yeah, so people tend to deploy certificates in HTTPS internally in their own systems, behind the scenes, not just for front-facing web properties, and that can be fraught with problems. And we're going to kind of go into that throughout the talk. So, again, a little bit about me. I'm a software engineer in test. I've been a developer. I've been a program manager. I've been a product manager. And more specifically, and kind of where my heart lies, is developing software to test software. And I had a really good opportunity to do that when I was working at Microsoft. I came in at the tail end of the IIS 7 development. These demos will be using IIS 8. Yes, I did patch it. And I had an opportunity to kind of work in this space as my first job sort of out of college. I worked with a really cool developer. We got to learn a lot about it. And again, I've been working in software development for the last 9 years. And the thing that I've noticed is that certificates constantly keep coming up. People want to use them, but it is sort of a black magic. It is sort of a mystical art, especially if you're deploying it for the first time within your companies. So this talk specifically, we're going to go, if you've never ever had to work with server certificates, this is going to give you a quick introduction to it. We're going to talk about server certificates. We're going to talk about certificate authorities. And we're going to talk about trust chains. Just as a quick show of hands, are there people here who have never ever used these before? Have there been people here who have deployed their own CAs? All right, you guys know more than me probably. How many people have run into trouble after they've deployed their CAs? Bam, see, same group of people. So we're going to kind of go in. I'm going to describe a simple microservice architecture. It's going to be an HTTPS API endpoint. We're going to have a client talking to it. It's all going to go be secured with HTTPS, the certificate. And then we're going to look at some of the bad practices, and we're going to identify some sort of trends in what makes these things vulnerable. And that's both from a client side, so the client connecting to your service, as well as the service side, what makes it vulnerable. And not vulnerable in the security sense all the time, but as well as being up and highly available. And then we'll talk about some real-life examples, a bunch of links. I happened to be at Microsoft during 2 of these incidents, which was cool, because then you got to see people running around trying to fix certificate problems. Finally, we're going to kind of talk about the pros and cons of implementing certificate authorities, and specifically thinking about why you're doing it. Just that last talk that we talked about, if you were here, you're like, everything should be over HTTPS. I would argue in some cases that's not always the best thing, depending on what you're trying to secure and depending on what you're trying to do. And the key thing is it's always finding the middle ground, implementing what you need based on your requirements, and identifying how you're securing your critical infrastructures. So let's jump into it. Certificates. We're just going to take the really quick and easy way to do this. This is the Wikipedia definition. An asymmetric, cryptographic, public key with a verification signature. It's a way to share secrets. But built into it, which is really cool, is a way to verify that who you're encrypting your data with is actually who they say they are. That's what really makes it key. It's both an encryption mechanism and an authentication and a trust mechanism. We use it most of the time in HTTPS, connecting to a web endpoint. It encrypts that communication. You know that you encrypted it with one certificate. It's going to go over the wire. It's going to get decrypted. Can be used as an authentication mechanism. So people who use client certificates, I issue a certificate to you. You authenticate to my service via your client certificate. I know that it's you, and you're only talking to me because I issue you that public cert. Last but not least, these certificates are only valid for a period of time. They have a specific validity period, and anybody who's deployed their own CAs know that certificates expire. How many people have been caught with an expired certificate? So, certificate authorities. These are trusted authorities that issue digital certs. These are the people who sign certificate requests and basically say, I trust that this person is who they say they are. They're kind of a middle point. They're somebody that you can verify against, and I'll kind of go into an example here in a few minutes. It's used as that common point of reference to determine if you're a valid certificate. They also publish the list of like a certificate revocation list, a list of certificates which are explicitly not to be trusted. If for any reason a CA is compromised, you don't want people using those certificates. Maybe they were forged. Maybe people were making certificates in your name. So there's a lot of reasons why you don't want to trust somebody, even though it's been signed in the first place. The other really interesting point is that root certificate authorities are installed everywhere. Everybody has them. If you use your phone, if you use your iPad, if you log into Linux, Windows, or Mac OS X, there's a set of root certificates that are already installed on the box. It's a very unique, special thing that makes sort of the web infrastructure work the way that it does. I, as my own certificate authority, can't become one of these people who is installed on the box. And we'll go into more details on that here in a minute as well. So we talked a minute about revocation lists. These are, again, lists of certificates which are explicitly not trusted. They're published by authorities, so as you're going through a trust check, you want to know, hey, did you revoke anything? Should I not trust anybody that I'm talking to? And it's kind of paired with the validation of a certificate. So what makes this all work is being able to identify a trust chain. So I have my own certificate. I go to VeriSign, and I ask them, please sign my certificate request. And then they sign it, and they give it back to me, and I put it on my website. Then when somebody accesses me, they come and they talk to my site, say, hey, here's my certificate. And they're like, who signed you? And I say, VeriSign did. And VeriSign's like, yep, totally did. Rock on. In that case, VeriSign is the root CA. So how can we make this in more readable terms? I have a passport. I am now giving my passport to a bouncer. That bouncer looks at my passport and he does some checks, right? He basically opens it up, he looks at it, determines if it's forged, checks my birth date to see if I should go into the bar. Bouncers of Zeitgeist are very picky about that. They're only going to take, certain forms of identification. Hopefully my passport is, valid. But the important thing here, what makes this really interesting is the State Department issued my passport. And I have an implicit trust to the State Department, and the bouncer at Zeitgeist also has an implicit trust of the State Department. That is kind of the root authority. We both agree that whatever they give out is trusted. Now, if we go through the same sort of example, if I were flying into SFO, I hand them my passport, I hand it to a border control officer, he opens it up, but what he does is he looks at it, he determines if it's valid, as well as scans it to determine if it's been suspended or revoked, or if he should do anything else. So he goes through a separate sort of trust chain to verify that my passport is who I say I am. This is the authentication side of it. This isn't really the cryptography side of it. And this is kind of what ends up being more fraught with troubles and dangers. Not necessarily like, are we using the right encryption algorithm, but more of, is the system going to work when I go and issue out certificates? So a lot of companies do this when they go and they create their own certificate authorities. This is a basic sort of trust chain example. You create your company's root certificate authority. You create some intermediate authorities. Sometimes the root certificate issues, their root authority issues certificates. The intermediate authorities issue certificates. And if you want to think of an example, it's I have a VPN server and I want to have people authenticate with certificates. So I create my VPN certificate authority. And then maybe I'm using mobile device management. So I'm going to create my device certificate authority. But they're all anchored by my own internal company certificate authority. So we want to look at it one level further and kind of what we're going to highlight here for some of the demos. Up top, we have what would kind of be like the web-facing side of the world. If I'm going to create a web property, if I'm going to go put a website up, I need a certificate that everybody trusts. So I'm going to go get a certificate signed from a top-level authority, GoDaddy, VeriSign, DigiCert, whatever. When somebody comes and connects to me, they're going to verify that certificate via the root authorities that they have built into their mobile devices or on their OSs. That doesn't work the same way if I built my own internal certificate authority. I have to find a way of getting that trusted root authority onto all the boxes that are going to verify it. So here, hopefully this example kind of makes sense. We have a web server that's doing some work, and then behind the scenes, that web server is now talking to some sort of job server, again, using the microservice architecture. It has an HTTP endpoint, but it's using an internal CA versus, DigiCert signed CA. Cool. All right. We're going to kind of keep rolling with this. So I'm going to give you a quick demo. I'm going to kind of go through a few examples on my box. And let me know if this doesn't make sense or if I should explain more. I'm the last talk of the day, so I'm between you and whatever parties you might be going to. Here, this example, we have a web service that's just an HTTP REST service. We have a client application that can be a mobile client, that can be another web server, that can be anything, just talking HTTP to my REST service. And then in this example specifically, the client app is sending credit card data over HTTPS to the service, and the service is just storing it. So we have some sensitive data that we want to protect. And the other key thing is the microservice, the REST service, has its certificate signed by an internal CA. I created an internal CA to sign the certificate. So, demo time. All right. Who wants to see a demo? Woo! Okay. Now, I didn't practice it this way, so we're going to do a little bit of, we're going to kind of pivot and turn and hopefully not get in the face with the microphone. Say that one more time. That is, it's all in one. I wanted to tell you that this year, that's what the DEF CON badge is going to be. I actually just changed this background to be less nerdy. It was like an ocean pick. I just found something from last year that I figured people will get kicked out of. Okay, so real quick, we're going to kind of just show off what we got running over here. So right now, I'm going to use a couple of tools. I'm going to use Postman to just make web requests to my service, just an easier way to show it. And then I'm going to show you the client application making requests to my service, and then we're going to read some data back and forth. So number one thing, let's talk about the service itself. So let's go to my endpoint. We'll notice one thing when it starts up. Here I have that lovely lock that everybody loves. Chrome trusted it, which is awesome, which means obviously I'm sharing information correctly. It has one problem with it. It's kind of complaining that I don't have audit records. It let me log in, so I really don't care. And then it says, hey, we trust this. And if you want to look at the certificate, Windows, it thinks that my certificate's okay. You can go to the details. You can go to the certification path. Certificate is okay. You can't read that. You can trust me. And then here, the root authority, its certificate is okay. It's because I've installed it on this device. Now, what's the big difference between like a web browser client and like another client, like a mobile client that's connecting to my service? So suppose that I go to maybe an evil endpoint. Okay, so if a web browser notices that there's something wrong with my trust chain, Chrome, every browser now does this. It basically says, I shouldn't go to this website. I'm going to actually make the end user make a decision if they should continue sending data to this website. Specifically, it says, the certificate authority is not valid. And my first option is back to safety. It's not, okay, keep going. I have to click an advanced button, and then I said it couldn't prove it, and then I say that I can go on. So we're gonna stay away from that website. Just for the example perspective, wow, this does not scale well. We're making a GET request to the endpoint. There's some credit card data already on the server. We're going to post some extra data, so Johnny test. We're going to send it along. Here it's getting a 201 created. And then if we go back and we say, hey, give me that data, we show that it stored it. That's basically the premise of the service. And then we're going to go over here. If I can drag this back over. We're going to run this client's application, which will spin up in just a moment. And here, we're just going to be, every 5 seconds, we're going to create a new user. We're going to store some sensitive data. We're going to store some credit card information. All right, so any questions about this service, the idea behind it? Real basic. I got it. Cool. All right, let's jump back into the presentation. Let me make sure. I took notes to make sure that I wasn't skipping anything. Yeah, that's pretty much it. Real simple service. But it's the simple services that are the ones that we depend on. So, going back here. Crap. This is where my start from current slide. Cool. All right, so let's talk about how this service may be vulnerable. So, who is the certificate authority? Is it online or an offline certificate authority? How much data is being published online? Where do I get my intermediate trust certificates? Where do I get my CRLs? Simultaneously, if you have a client that's connecting to it, how do you know that that's properly configured? What is the level of trust in the certificates? Is it doing error handling correctly? What protocols are being used? You may have spent, 6 months and a whole bunch of money and a whole bunch of time making, a certificate system, setting up HTTPS, and find out that everybody is still talking HTTP to, your service. What's the point? Again, trusting too little or too much, and then the error handling specifically, that's a challenge. Like, developers are lazy. I, being a developer, am lazy. And when I'm testing these things, setting up a trusted chain is often difficult in my development environment. I can't go to my operations team and say, please give me a valid certificate. They're going to be like, why would I do that? I'd have to revoke it anyway. So let's talk about kind of the first vulnerability, what we all think of as a vulnerability in the security sense. This is the man-in-the-middle example, right? I have a client's application. It has been tricked into going to the evil microservice, which is then turning around and relaying the information back to the good one. It doesn't matter that it's relaying it. It's basically sitting in the middle, right? Everyone's kind of familiar with this concept, with this idea. And there's a lot of different ways that you can trick a client application to kind of force you to go somewhere you don't want. For example, the GoGo thing where they were intercepting all traffic, they were sitting in the middle. You know, if I get somebody on a phishing attack, can I get them to update their configuration on their phone to post to some other random endpoint? You know, these things are problems. This is why understanding how your client application works in regards to this system is important. So the next fun thing is let's demo this. Let's try this out. So, and just a quick question: if you're up close, you guys can read this, right? Yeah, cool. All right. So what we got going on here is okay. Drag everything over. So let's stop the service. Let's take a quick look at the code. So I'm going to basically fake my config being compromised. So we have a client, we're posting data, and now I'm compromised. That sucks. And if we take a look here, we're going to notice something. I'm going to post data. Oh, crap. It's still working. Why is that still working? That shouldn't be happening. So let's go figure out what's going on. So I changed the endpoint, right? It's still working. It's still posting data. My client thinks everything's fine. And even from my perspective on the site side, you know, that's a lot of people. Mindy Stone, did Mindy Stone get created? Yeah, Mindy Stone got created. You know, everything looks fine to me here. Remember that evil website that we were talking about a few minutes ago? That I shouldn't have gone to? And it goes, oh man, it's an evil API, and they're posting all my secrets on this website. So we're getting man in the middle. It's very straightforward. What's different is that my client application didn't care. It was still posting data, still throwing data up there. Didn't do any checks. Why did that happen? As an end user through a browser, I got blocked. I got stopped, and they were like, you should not go here. Something is really, really wrong. Let's go figure out, whoops, thank you, Windows. Let's go figure out what's wrong. Let's take a look at one kind of area. Can anybody spot the bug? I will buy you a beer if you spot the bug. Anybody? 3, 2, 1. Okay, that's okay. This is some crazy C#. This line right here. If you ever get bored, go search for how do I bypass certificate checks. And you will see examples for Android, iOS, Windows. Yeah. Super simple line. We can talk about C# and delegates, but this is, wow, holy crap. And I have seen this. I've actually seen people write this code in production systems because they are setting up an HTTP service. Like this just makes it easier for me to test. I know that it works, and I don't have time to set up a trust chain. So this is a bad bug. This is a dumb bug. Let's fix it. I really should delete it and put a comment say never ever do this, but we're hacking, right? We're at BSides. Okay, we're starting it up again. Now we get this. Now we're broken. That sucks. Well, it's good, right? Because we don't want to send data to a bad website. This is one way to protect our service. We want to at least trust that we're SSL and we're sending it to trusted certificate endpoints. So this is one aspect of the problem. So I don't want to keep sending errors. Let's go back to base URL, the happy fun one before I got compromised. Maybe I wiped the device. Cool. And then we'll let that keep running. And then key thing here, we have validation now. It's a trusted endpoint, and the application continues to run. So it's exactly what we want. Cool. Awesome. Things are rolling. Now let's talk about the problems with strict certificate checking. Okay? We fixed the bug. Everyone loves fixing bugs, right? We're more secure than ever. Bad certificates aren't going to harm us anymore. But now we need to know all of the various ways that our infrastructure can fail behind the scenes. When does that certificate expire? Is that certificate revoked? Did the CRL expire? Because that's part of your trust chain. Are there connectivity issues to the places where I'm trying to validate that the authorities are valid? Do I have a fully trusted chain? So, how much information leaks? It depends. Your CRLs are very public. Those things, it really doesn't matter because it really just has the signature of the certificate and says, don't trust this. So, it's an interesting question. So I'll be better about it answering responding. So the question was, should I be worried about leaking data? It depends. And for the most part, CRLs, even CRLs for root CAs, they're HTTP. It doesn't really matter because it's built into the certificate itself that that's the endpoint that you should validate. And they want to make that very easy to get. So optionally, if you intercept that and then you start inserting certificates, you can cause a problem. So that's a very unique way of attacking. So here, this is the fragile system that we have in place right now. My certificate authority signed certificate. And if you notice that this is a lot of repeating of the same words, when I was practicing this, I realized that was a big problem. So my service has a valid cert. The client application has to go to the internal CA to determine if it's valid. There's 1,000 different ways that this can break because you're encrypting, you're sharing encrypted data, and things can go really, really wrong if you're sharing data with the wrong people, as we saw earlier. So one more demo. We're going to go into what happens when we break trust, when we revoke certificates, and then if we, just fail to even follow the protocol. All right, so while this is going on, I want to make sure that this is still running. And we're going to do some adjustments here. So while this is going on, and I'm going to bring up, I don't actually have, I'm actually in airplane mode right now to make sure that this all works. The way that we're going to kind of do this is I like Windows for these demos because Windows has its own internal certificate management. It makes it a little easier to experiment with. You can do all of this stuff via OpenSSL and via Mac OS X or Linux or anything like that where you have access to either the keychain or your own trust chains. You can revoke certificates and you can do a lot of this. And setting up a service like this makes it a lot of fun and kind of makes it more visual. So the number one thing that we're going to do, as I go back to my handy dandy notes, the key thing is we're trusting the internal CA. So if I go to my trusted root authorities here, we're going to notice that secure our Lucero test, my root CA is installed to the trusted authorities. And if we go back here, I want to verify the certificate again. My certification path is USS Endeavor, and it was signed by secure our Lucero test. And what we're going to do is we're basically going to remove that implicit trust, and we're going to see what happens. So if I, come on Windows, delete this. Windows really doesn't like you deleting things out of the root CA. Obviously they got placed there for a reason, unless you got compromised. So that's a good reason, yeah. So, okay, other fun thing, I noticed this while I was setting up these demos. When I refreshed it, it's still trusted, right? It's holding on to that session. It's Chrome and Internet Explorer both did this. So we actually have to do the really ugly, start up another one. Let's try this. So I'll slide this over in just one second. Okay, so this is IE. IE's saying the exact same thing. Oops. Click here to close this web page. Why is it not trusted? And it's not telling you much. Windows doesn't give you, or Internet Explorer doesn't give you that much information. There was a way to do it. If you continue to the website, you get the big red bar again, and if you view the certificates, it says, cannot be verified up to a trusted authority. So even though I created the certificate for my service, and I trust it, I don't have the capability for clients to verify the root authority because I deleted it. It's not there. And I don't have a way that you can get it over the web. And if we were to look in the details, sometimes you have information about where you can verify that root authority. So that sucks. We should go fix it. I like running a trusted site. So I'm going to go back over to this side because that's where I have it installed. Let's quickly fix this problem. So we're going to import this. Other important point of note, don't do this unless you know what you're doing. Adding random certificates to your trusted root authority is not recommended. But this is just my machine, so hey, why not? So yeah, see, it's telling me that I'm trying to trust the root CA. The import was successful. And then if we go back to Windows IE, come on. Cover cert API, and then we're back in business. Okay, so that was one. The next thing you want to do is let's talk about how do things look when we revoke them if I explicitly don't trust them. So suppose I bought my certificate from super cheap hoster and VeriSign revoked that certificate. That would be bad. We want these things to work. I like it when my certificates are trusted. So suppose we do this. Suppose we drop the root CA into my untrusted one. And we go through the same route again. We should have just saved it like this. Bam. Click here to close the web page, and if I click more information, damn, this is right, because I did this all through Chrome. We're kind of doing it live on a couple of these demos. Let's go take a look at Chrome's. Yes. Internet disconnected. Oh, oops. That's because I tried to search. Okay, that didn't work. I think I revoked the wrong thing. That's okay. We can revoke a whole bunch of things. Use this endeavor. And again, we're doing this live, so let's close all windows. Let's bring this back up. Bam, there we go. Okay. That was one thing that I did want to point out. I forgot which one did it. I was practicing a little bit too late last night. Chrome is really good about kind of expressing like what's broken. And if you notice here, now that we broke the certificate of authority, we'll notice here that my client, while it was continuously running, has started to freak out again. Like, so this is good, but it's bad in the sense that my certificate's revoked. This means revocation is working. We want to test these systems because if I do spend money on a certificate or I do build this system, I want to know how it behaves when these things go down. This is a really big problem when people go off and create their own internal CAs. And we'll talk about that here in just a minute. But just because, we want to make sure, we want to see things running, we want to see things work. Let's go delete these. They're no longer revoked. And we'll see it again. Come on, Zach Green. Thanks, Matthew Lucero. Cool. We're back in business. So, what does this mean? What can we learn from this? Big companies are affected by this as well. Every single one of these issues was related to a certificate and resulted in a major corporate outage. I was lucky enough. I didn't work on these things at Microsoft, but I had the opportunity to talk with some of the people who worked on them. And it's a very, very interesting problem. And again, for everybody here who runs their own certificate authority, you know how much trouble this can be. The first one had to deal with an expired certificate. Microsoft was notified 180 days in advance that the certificate was going to expire. Weren't able to get it on the boxes due to a different bug. The service disruption, the second one there, February 29th, subject to leap year problems, right? Most certificates only have a lifespan of 1 year, unless you're explicitly overriding that in how you're issuing it. If you're running your own CA, 9 times out of 10, it's 1 year. Google, their trusted root authority was compromised. They were off issuing certificates as if they were Google, right? That just happened in the middle of March. And then as I was searching around for this, smtp.gmail.com, one of its intermediate authorities expired, and Gmail was not sending mail for like 2 or 3 hours. So these things are critical. These little certificates that we depend on so much, like they're part of our systems, and we need to make sure that we know how they work. So yeah, ChinaNet getting revoked. All right, so let's talk about the pros and cons of internal CAs, and we're going to kind of wrap this all up here because I think we're coming to the end. The pros of running your own internal CA. You have control. You get to control everything. That's one advantage of running your own thing anyway. You get your secure encrypted data that you wanted. If you did want to SSL pin things, you know that it's really trusted. You control both the certificate as well as the pinning on the other side. And if you do have to reissue or you do have to revoke, it happens much faster, assuming that you manage and monitor it effectively, which is the number one con. These things are very difficult to manage and monitor. If they need to be highly available, you have to build them that way. Bad implementations will underprotect systems. So if I'm a crappy developer and I write in my certificate bypass, no point in having the service. If I'm not implementing it correctly and I'm giving all of my certificates 30-day expiration periods, I'm going to have outages like we saw with the example of the client application. If somebody were to get into your system and find your intermediate authority, they can now issue certificates as if they were you. That is really bad. That's a dangerous thing. So these are very protected systems, or they need to be, depending on what they're being used for. If it's for people to access your VPN, now you have random people who you don't know getting access to your VPN. And the other hard part about running your own internal CA is that you have to be able to distribute your root CA or make it available for people. Unless you manage the machines, you have to go tell somebody, hey, go put this certificate on your box. Oh, you know those warnings that Windows said and probably Mac OS X said? Oh, why are you installing a trusted root authority? Just ignore those. It's okay because it's my certificate or it's our company's certificate. So how do you find the middle ground? When you're building these services, if these are all way, way behind the firewall, maybe, and you're storing data that isn't that sensitive, maybe you don't need it. People will argue with me probably left and right about that. But identify the risk areas. Build the systems in a way that you protect your key areas. Again, design and implement it accordingly. Do you have to protect the whole world? How many individual microservices do you have to protect? How many endpoints do you have to protect? And then weigh the costs. If you only have to protect like 6 endpoints, maybe it's just more cost effective for you to go get 6 DigiCerts. You know, put a calendar reminder, update them once a year, drop the whatever $600 it would take to keep those up and running. Save you all the headache of going in and creating your own internal CA. Here's some tools that you can kind of use and think about it. Windows, I love Windows again for this because you can just open up the certificates, or you can use certutil. And OS X and Linux, OpenSSL does everything that we were just doing. You just go from the command line, you just run it, it dumps all the data, it says if it's valid or not. When you get a certificate, open it up, review the expiration date. Go look at all the endpoints that it relays you out to. Does it have an internal authority? Can you access that intermediate authority? And then access the CRLs, make sure that they work, make sure that your systems can access it. I recently had an experience talking with a group of people where they couldn't access a CRL because their firewalls were way, way too strict. If you're working on clients or people that are talking to, microservices or service endpoints, code reviews are critical. Have people who are familiar with these services, understand them. Test with all the various expected scenarios. If you're going to build these, test them right. It's hard and it's time-consuming, and people will argue about them, but argue with you about them. But it's really important. And then if you're using SSL pinning, test your rekey strategy. If you have to revoke a certificate that it's SSL pinned, you're going to hurt a lot of people if you can't rekey it effectively. And this is it. Know what you're getting into before you set up your own CA. Test and monitor. Have practice drills. Be able to redeploy. Be able to revoke. Be able to reissue. And then document and identify your system. Just be proactive about this system that you're building. And that's pretty much it. If you have questions, you're welcome to email me or ping me on Twitter or LinkedIn or whatever. I will put these slides up. I made some last-minute changes. They'll be up on GitHub. And again, for anybody who has questions, feel free to ask now. I've been